Welcome to the Week 2 assignment review. I'm just going to go through a couple images from this week and just point out small deficiencies just so everybody can learn from each other's mistakes. So what we have here is a very good example of the reconstruction. The eyes are looking very good. Maybe a little bit high up just because if we're looking at the clearance between here and here, right, essentially this superior tarsal plate is probably scraping along the top of the orbit. And really we need a little bit more space. We have the levator muscle that goes up in there to retract the eyelid. And we still have to wedge all this nice teardrop shape of fat up medially, so probably a little bit more space. We have to get one of the lacrimal glands in here, so a little bit too far up. But beyond that, the construction is really good. What I like about this is a good sense of the thickness of the lids, right? And this is what I've kind of tried to reiterate to most people in their assignment reviews is depending on the angle with which you're looking at the eye, or the camera is looking at the face, if you're looking from below or the eyes are looking up, you have to really be careful as to how much of the thickness you show. And also the other kind of equally important thing is to get the flow of the lids across the ball correct, right? So a lot of people have problems with this on the lower lid. When you're looking from below, kind of everybody wants to do an eye that's always like this, right? You always want to draw an eye that's kind of an almond shape. But when you look from below, we're getting the crescent aspect of it, right? This lower lid is still attached to the ball, and so it's being wrapped around almost on, think of it as latitude lines on a map, right? Or on a globe. And so that's the secret, right? You wrap it around, and then you give the upper lid thickness, right, as you're looking at it from below. Okay, and then that continues on. Lower lid has thickness out here as it drops off the ball of the eye. Okay, no problem. Now, the next thing I wanted to point out on this is kind of a mistake that a lot of people were making, and I'm not sure if it's a deficiency in my teaching. I hope not, but everybody did really well placing kind of this anterior portion of the masseter, right? And this is by far the most prominent one, but what fills in the back here? I mean, we talked about the salivary gland, right, that sits back here, but actually there's the deep section of the masseter. Remember, fills in right in here, right? It's going to come up under the zygomatic arch, the same as this, but it's at a plane a little bit deeper because this anterior portion is creating most of the convexity of the cheek here, and then this is a little bit of a step down, right? So in life, on somebody who's reasonably thin, you can actually see a difference in planes between this section and then hitting the back, kind of this deeper section of masseter. Okay, so keep your eyes out for that. This was a common mistake on this week's assignments. Okay, this image shows the construction from the side, and we're looking at temporalis, masseter, and those look fine. Actually, we have kind of, if we were going to divide this into the kind of the more superficial and the deep portion of the masseter, it would be kind of along this axis. So superficial along here, and then the deep portion going up here. But that's all reasonably fine, right? What I wanted to show on this one was another common mistake, and that's to do with, well, two things actually. So assuming the placement of the eye is reasonably good, and I'm just going to dot the roundness, and that's fine. Big thing for me in the profile view, the eye, you have a huge advantage in profile because the eye actually just becomes a wedge. The lids end up just becoming a wedge shape, sticking out. The cornea is the convexity of the eye, the kind of the front profile of it. And I'm showing kind of thickness in lashes, and a little bit sloppy, a little bit hard to read actually, not sloppy necessarily. I don't think changing color is actually going to help, but that's the secret. Always a wedge shape in the profile. And then remember, the other thing that you're looking at is you're looking at about this much distance of kind of lateral canthal tendon to the inside of the orbit, right? And if we look carefully at the skull here, you can see this fissure between the zygomatic bone and the frontal bone. And again, on average, we're about a centimeter below that to this fissure. But when I talk about these averages, a centimeter, we're talking about 1 centimeter plus or minus half a centimeter, right? If you're talking about an average across the population, there's huge variability. And that variability is actually what makes everybody's face so unique. So this is kind of the ballpark that's going to get us close to a good average face, and then we have to observe this variation, right? That's why we look carefully at people's faces. Okay, so that's it. Remember, in profile, you get to do a little nice cheat and just hit the wedge shape for the eye, and then the important thing is to locate that relative to what ends up being the nasal bone, and also kind of the sunglasses in the turn of this plane, right? Essentially locate it relative to the lateral section of the orbit. Okay, that's all for this one. Okay, this image is a pretty nice construction over the Nymphs and Satyr painting, and for the most part it's very well executed and captures the critical kind of construction that we've been talking about. But the one thing that I wanted to point out that's kind of that I've seen consistently across assignments is remember to treat and to just kind of visualize, or at least think about, the fact that the female skull is different, right? So on this guy, I'm not worried if you go in and you drop a kind of a huge kind of masculine jaw on him, right? Big kind of deep kind of ramus here, and then nice prominent chin. But on these females out here, right, this is where you start to see delicate angles, a nice rounded chin, and quite a bit shallower in this this dimension, less steep there, and nice and round there. So looking at this up in the kind of the top right, this looks like a man's jaw to me, right? A female jaw is going to kind of take some of those dimensions out and end up being soft and a little bit more gentle, a bit like that. And kind of concurrently, hand in hand with that, I know you can't see too well on this image, but remember that when you're getting down to the chin, right, just feel it for yourself. Like if this is the bone and this is the teeth, I know this is kind of a crazy chin. I don't think that helps. I'm going to continue with it anyways. Remember, if that's your chin, that you have actually a big wedge of fat. This is like the Joker's chin or something now. You've got a big kind of fat pad that actually sits on the chin on top of the kind of the protrusion of the jaw. So always remember that when you're kind of ecorcheting a skull, right? There's a lot of depth here. Less so through here, depending on the person. And then out here, remember, this is where we have the masseter kind of contributing this convexity, right? So there's a lot of soft tissue that fits all around here. So just keep that in the back of your mind when you're trying to visualize the skull inside of kind of a living, breathing human, right? That it's not always exactly what you see, except for these areas that are nicely exposed. Okay, I think that's all I wanted to say on this one. Okay, and now just a quick walkthrough of this resin painting, right? And I'm not going to crochet all the skulls on this. You guys have all seen that. I'll show you an example of a really well done one, though. But I just wanted to go through here and show you guys some of these areas where the skull is immediately superficial, right? And it's kind of it's the secret window in, right? And it's all along the zygomatic arch. You can see it on all these guys here, right? Before you get to a bunch of soft tissue, this is kind of what you see on most of these, right? You can see it quite clearly here, very prominent on this guy. And then, of course, masseter, everything kind of creating this plane on the side. Again, look at this guy laughing, right? All sorts of soft tissue modifying right here in the kind of the malar fossa, right? And so as soon as we turn the corner of the sunglasses, things start to get very malleable with soft tissue. But out here, on a skinny person at least, we're looking at nice exposed landmarks. As you get heavier, it's still pretty exposed out here, but all this down here, remember, starts to become covered with some fat and soft tissue, right? If you guys have been into your week 3 material already, you recognize a lot of these fatty deposits, right? So all these things overlap, but we're hopefully learning the construction that kind of scaffolds all that in place, right? Look at this nice arc through here. Consider that the convexity of the zygomatic arch. Ear hole sitting in there, and jaw going down, masseter, and jaw coming forward, right? A little bit inside the chin. Remember that depth that we were just talking about. So that's going in. Anything else interesting on this? Let me just pan around. So I think probably I've mentioned a few times the front plane of the face. I consider everything kind of medial to the lateral border of the orbit to be the front plane, right? So things coming down like this. Not to say that we have a front and then a 90-degree change to the side. No, it's more that you have the front plane and then you have the arc of the side plane, right? So you get convexity kind of coming off the sides. And so it becomes a gradual transition out here, right? Not a perfectly sharp transition, but we can reliably start to place things looking forward as soon as we get around this edge, okay? Everybody should recognize some really soft tissue right in there. Let's see, anything else interesting to me on this? This guy actually here shows something that you can see frequently in your kind of scanning of the general population if you look closely. You should always look for characteristics like this, right? Let me find a different color. I think this guy's skin is probably... Look at this convexity, right? Huge convexity down here, masseter, maybe fat. But then you see a really sharp line, almost too sharp, dividing it straight up to the zygomatic arch. Right, so on some people you can see a very distinct transition. And then in others it becomes very less distinct. It's just kind of held out by the convexity of this with smooth transitions above and below. Okay, again, very subtle tones, shifting the planes in through the zygomatic arch here. And this guy, if I zoom in, and we're getting into pixels, just looking at this, right, if you're placing the orbit, we kind of know that that anchor's there. Can extrapolate kind of the lateral border of the eye, the lateral kind of opening to the lateral wall of the orbit, right, because they attach by the canthal tendon. We're going to go way into pixels. But then on a raised brow, all this soft tissue is elevated, and so we can see quite clearly this upper boundary. And what it gives you, especially when you're looking up from this angle, is a little bony wall of the orbit, right? This is the transition plane between orbit and nose sitting in here. Right, and I think we saw that on, I think in the slides, it was one of the Louis Armstrong images where he had his eyes really elevated, he was blowing hard in his trumpet, and that gave us this transition from kind of bone to fat. And back to regular size, okay? We lacked a little bit of resolution there. Sorry about that. Okay, I think that is about it for this. Let me just quickly show you an example of a pretty well done écorché on this one. Okay, and this is a submission from earlier in the course. So you see this captures most of the angles, most of the construction that we talk about, right? So temporal line, zygomatic arch, location of the eyes, and does a really good job of wrapping the eyes based on their angle of view, right? So again, looking down on the skull, this is what you get, right? You get this crescent across the eyes. Looking up on the skull, you start to see a little bit more of this arc. This arc, obviously Repin was the source material for this, but this is kind of the exercise, right? It's good practice to reference all this stuff. And then I think what this exercise shows really well is the open jaw, right? So jaw opening, and these are kind of the critical things for us, especially when we get to the mouth, is how does the actual bony structure that we're studying relate to the surface. And essentially when the mouth is open, you need to kind of have a good sense of what you're seeing inside, right? It's kind of a window into the bony structure of the skull, leaving all the soft tissue on the outside. All right, so if you understand the convexity of the mouth or of the teeth, then you can wrap lips around it and do a convincing open mouth, do a convincing smile, etc., right? Things that are actually fairly advanced and difficult to do if you don't know about the skull underneath. Okay, so I think there's one more thing, and then I'll wrap up this review. Okay. Okay, and now finally, this is actually a very astute question asked by somebody. What is the angle of the opening? So, if you remember, this is called, the opening of the eye is called the palpebral fissure, and it's measured generally from, well, almost always from the medial canthus to the lateral canthus, right? And varying between race, with plus or minus a few millimeters, this on average is about 29 millimeters, right? Give or take. You can look it up yourselves. There's quite a variation in what people say is the average, and it's been well researched, but 29 is kind of a general average. Okay, so if you're actually trying to use that to determine how great this opening is, well, you'll actually be in trouble, because if we're just working on averages, you remember that the average eyeball is 24 to 25 millimeters wide, right, in diameter. Obviously, like we've said, it's not perfectly round, so in one axis it actually tends to be a little bit wider, side to side, so it could be a little bit more than that, but we'll use that as our working measure. So in fact, that your opening is actually bigger than the eyeball itself. And so actually what we have to account for is we have to account for all of this lacrimal apparatus in here, right? So it varies from person to person, like everything, but I just actually measured it on myself, and I measured about 29 millimeters on myself, and this distance was about 5 millimeters. And so what we're left with is an opening in the eyeball side to side, if we just consider what's actually exposed sclera, the white part, of about 24 millimeters. Okay, and that again is almost this dimension. So this gets very, very close to the actual diameter of the eyeball, which means that it would actually subtend this angle. If you converted it, it would be close to 180 degrees, but we know that's not the case. So we'll assume that there's a little bit extra width here, and that probably the opening of your palpebral fissure has a correspondence to the actual diameter of your eyeball. So if you have a bigger diameter, bigger opening, you'll say that probably your eyeball is a little bit bigger, right? Because we have to have a little bit of variation here to essentially keep the eyeball from falling out, or keep the all the rectus muscles from being exposed when you look around. And so I just wanted to clarify this with a quick look at some scan data, so we can actually kind of zoom in on this guy and see if we can get close to a consensus on this, just with some practical measures. Okay, so as we zoom up and down, we're going to get to about, so what I'm looking for is I'm looking for kind of the center of mass of the eyeball, the biggest convexity, and it's about here probably. Right, and so we'll consider, see the wrap of the eyelids, right? So this is going to be kind of the lateral canthus to, I would consider this probably the medial canthus, and this guy's sitting about 29 millimeters, right? As I've measured it in fairly abstract units. This doesn't take into account all the goo of the eyeball, which is about 5 millimeters, just like I don't know if you guys can see this, it might be getting too small. I'll read it off. It's kind of what I just measured with my calipers on my own eye, and then we'll just look at the width of the ball of the eye side to side as near as I can tell, and that's sitting about 24 millimeters. Right, so depending on how you measure this, we're looking at nearly equivalent openings. So let me just do a quick slice here. Say our goo comes to here, so I'll just do a quick measure, and we're going to kind of go to the inner opening, and this last one says 22 essentially millimeters of the opening, which is cool. And let me see, I think I might be able to even get an angle here. So here we go. I'm going to try to do an angle from here to here to here, and this says 120 degrees, right? And practically that's kind of what I would expect, right? And I'll just try the same thing from here, roughly through the center of mass of the eyeball to where I would consider the opening, so 120 degrees. Okay, so 121 degrees, 120 degrees. Again, just a quick visual test on some actual physical data. So conclusive or not, I don't know, but that's what we've come up with. And visually, that kind of makes sense, right? If you're subtending this kind of angle on the eye, this arc looks like it's going to be about 120 degrees. And that's kind of, this is a well-drawn, actually, image, because That's typically what you see if you're looking at somebody's eye from below. Okay, so that's it. A little bit of analysis to end the review. Hopefully, it's kind of interesting. Obviously, nobody's going to be in there measuring these things by hand, but it's good to know. And one other thing I'll just drop in here before we finish, just so that you know, the average, as we're going through all this stuff, the average diameter of the cornea, right, corneal diameter, is about 12 millimeters. In fact, it's more like 11.7, plus or minus a few. But that gives you an idea. If the if the average opening is about 24 millimeters, then it's about half, right? So if this is 12 on this side, this is 12 on this side, and all this stuff in the middle, cornea is 12. Okay. The end. Hope that's kind of interesting. Probably just you have to rewatch it. Anyways, good luck with week number 3.